Assalamu alaikum. Dear students, I am Hasnia Zahra. We will discuss very important phenomena, total internal reflection. Before discussing in detail total internal reflection, we will discuss reflection of light. First of all, we will discuss its definition. According to the definition of reflection of light, when light traveling in a certain medium falls on the surface of another medium, a part of it turns back in the same medium. This is called reflection of light. The medium should be opaque. According to the figure, we can see the angle of incidence and the angle of reflection will be same. Now we will discuss the laws of reflection. There are two fundamental laws of reflection of light. The first law is the angle of incidence is equal to the angle of reflection. We have observed it already in the previous slide. The second law is the incident ray, the normal and the reflected ray at the point of incidence all lie in the same plane. Now we will discuss refraction of light. The process of bending of light as it passes from one medium to another is called refraction of light. This bending occurs because light travels at different speed in different medium. When light enters a new medium, its speed changes, causing the light rays to change direction. According to this figure, we can easily understand the concept of refraction of light. There are two different mediums. The light is traveling in medium 1 and falls on the boundary of medium 1 and 2. The medium 2 is a transparent medium, so it passes through the medium 2. But we can observe that in medium 2, the light is bending towards the normal. It means angle of incidence and angle of refraction are not same. This also shows that the light is bending towards the normal, not away from the normal. Why light is bending towards the normal? This happens only when the light enters from rare to denser medium. It means medium 1 is rare and medium 2 is a denser medium. We will observe an opposite phenomena when light ray enters from denser to rare medium. When enters from denser to rare medium, it bends away from the normal. We will discuss in details when we discuss total internal reflection. Now we will discuss laws of refraction. The incident ray, the refracted ray, and the normal at the point of incidence all lie in the same plane. This is the first law. The second law, the ratio of the sine of the angle of incidence to the sine of angle of refraction is always equal to a constant. That constant is symbolized as n and also called refractive index of the second medium with respect to the first. This ratio of sin I of sin R is also considered as Snell's law. Before understanding the concept of total internal reflection, we will understand the concept of term refractive index. Refractive index is the ratio of speed of light in air or vacuum to the speed of light in the medium. It is a unitless quantity because it is a ratio between the two same physical quantity. The refractive index also determines how much the path of light is bent into second medium. The bending of light in the denser medium depends upon the speed of light. As the light passes from air to glass, its speed changes. The speed of light in glass is less than as compared to the speed of light in air or vacuum. The speed of light in air is approximately 3 into 10 raised to power 8 meter per second, and the speed of light in glass is 2 into 10 raised to power 8 meter per second. Due to this reducing speed of light in glass, the light ray changes its path and bends towards the normal. Bends towards the normal when enters from air to glass. But when light enters from glass to air, it bends away from the normal. And this phenomena, the bending of light away from the normal, will be used in total internal reflection. Now we will discuss the term critical angle. The concept of critical angle will be very necessary. The critical angle is the specific angle of incidence at which the light traveling from a denser medium to a less dense medium, for example from glass to air, is refracted along the boundary between the two medium. As we know that when light enters from denser to rare medium, it bends away from the normal. And if light enters from denser to rare medium with the angle of incidence is such that the refracted angle becomes 90 degree. In that case, the angle of incidence is called critical angle. And the value of this critical angle vary from medium to medium. The angle, we can discuss the critical angle of glass is 42 degree. And its value will be different from water. Now we can easily understand the concept of total internal reflection because we have in mind the concept of critical angle and the refraction of light from denser to rare medium. We keep in mind that the light is entering from denser to rare medium. When light enters, it means that the angle of incidence for the light is greater than the critical angle. There is no refraction occurs because the light bends more than 90 degree away from the normal. When it bends more than 90 degree, it bends inside the same medium. The entire light is reflected back into the denser medium. It is very astonishing concept that both medium are transparent, glass and air, but the light will not enter in the rare medium. The reason is only one: the angle of incidence is greater than the critical angle, and we will observe the phenomena of reflection of light which take place when the medium is opaque. But now both the medium are transparent medium, but the light reflected back in the same medium. With the help of this diagram, we can easily understand the total internal reflection. When the angle of incidence is less than the critical angle of water, the ray of light enters in the rare medium, that is air. But when the angle of incidence, that is theta c, that is the symbol for critical angle, the ray of light travels along the boundary of air and water. But when we further increase the angle of incidence, that is, now it becomes larger than the critical angle, the ray will not refract, it will reflect back into the water. In that case, we are symbolized theta 1 and theta 2, but actually that is obeying the laws of reflection. The angle of incidence should be equal to the angle of reflection. It means theta 1 will be equal to theta 2.